Question 3, Part C. The diagram shows a line L1 with equation 3x plus 4y minus 12 equals 0, which intersects the y-axis at B. A second line, L2, with equation 4x minus 3y equals 0, passes through the origin O and intersects L1 at E. Part 1. Show that the coordinates of B are 0, 3. Point B corresponds to the y-intercept of line L1. Now the equation of line L1 is 3x plus 4y minus 12 equals 0. So to find the y-intercept, we let x equal 0 in the equation and solve for y. So substituting 0 for x in the equation, we get 3 times 0 plus 4 times y minus 12 equals 0. Now 3 times 0 is 0. So the equation becomes 4y equals 12, and then dividing the 12 by 4 to make y the subject, we get y is equal to 3. Therefore the coordinates of point B are 0, 3 as required. Part 2. Show that L1 is perpendicular to L2. Let M1 equal the gradient of line L1 and M2 equal the gradient of line L2. Now line L1 is perpendicular to line L2 if the product of their gradients, that is M1 times M2, is equal to -1. So we need to find the gradient of both lines, multiply them together, and if it equals -1, then the two lines are perpendicular to each other. Let's consider the equation of line L1. We have 3x plus 4y minus 12 equals 0. To find the gradient of this line, we need to express this equation in gradient intercept form, that is y equals mx plus c. So let's rearrange this equation. I'm going to start by making 4y the subject by moving the 3x and the -12 over to the right hand side. We get 4y is equal to -3x plus 12. Dividing all terms by 4 to make y the subject, we get y is equal to -3 over 4 times x plus 3. Now it's in the form y equals mx plus c, so m1 is equal to -3 over 4. Now the equation of line L2 is 4x minus 3y equals 0. Moving the 4x over to the right hand side, we get -3y is equal to -4x. Dividing both sides of the equation by -3 to make y the subject, we get y is equal to 4 over 3 times x. This is also in the form y equals mx plus c. So m2 is equal to 4 over 3. Now the product of the gradients that we just found, m1 times m2, is equal to -3 over 4 times 4 over 3, which equals -1. Therefore, line L1 is perpendicular to line L2. Part 3. Show that the perpendicular distance from O to L1 is 12 over 5. Line L1 forms a right-angled triangle with the x and y axes, where point A and B representing the x and y intercepts respectively. So triangle OBA is right-angled with OA equals 4, OB equals 3, and AB, representing the hypotenuse of this triangle, equals 5. So using the area formula, half times base times height, to find the area of triangle OBA, we're letting OA be the base of the triangle, OB being the perpendicular height. We get half times 4 times 3, which equals 6 square units. Now let AB represent the new base of triangle OBA, then OE is the new perpendicular height, but the area is still the same. Now OE represents the perpendicular distance from the origin to line L1, and that meets line L1 at point E. So using the area formula again, given that the area is 6 square units, we can form an equation, 6 equals half times 5 times OE, and then solve for OE. So simplifying this equation, we're going to multiply both sides of the equation by 2 to eliminate this fraction here. We get 12 is equal to 5 times OE. Dividing both sides of the equation by 5 to make OE the subject, we get OE is equal to 12 over 5. Therefore, the perpendicular distance from O to L1 is 12 over 5 units as required. An alternative way to find the perpendicular distance from point O, which has coordinates 0, 0, from line L1, which has equation 3x plus 4y minus 12 equals 0, is to use the perpendicular distance formula. So we have a point, 0, 0, and a line, 3x plus 4y minus 12 equals 0. So applying the perpendicular distance formula, we have in the numerator the absolute value of 3 times 0 plus 4 times 0 minus 12 over the square root of 3 squared plus 4 squared in the denominator. Now in the numerator, we have the absolute value of negative 12, which is positive 12, and in the denominator, the square root of 3 squared plus 4 squared is equal to 5. So the perpendicular distance from point O to line L1 is 12 over 5 units. Part 4. Using Pythagoras' theorem or otherwise, find the length of the interval BE. Consider right-angled triangle OBE. Now, OB represents the hypotenuse of this triangle, and EB and OE represent the two short sides. Now, the length OB is 3 and OE is 12 over 5, which we found in part 3. So to find EB, which is the other short side, knowing the hypotenuse and the short side OE, using Pythagoras' theorem, we have BE squared is equal to 3 squared minus 12 over 5 squared, which equals 81 over 25. So to find BE, we take the square root of 81 over 25 and we get 9 over 5. Part 5. Hence or otherwise, find the area of triangle BOE. In right-angled triangle BOE, EB represents the base and OE represents the perpendicular height. So the area of that triangle is found using the area formula, half times base times perpendicular height, and that equals half times 9 over 5 times 12 over 5, which equals 54 over 25 square units, or 2 and 4 over 25 square units as a mixed numeral.